CTC is an applied engineering and applied research firm. We do work associated with material science and advanced manufacturing techniques. We were looking for a lower cost, more affordable asset to do friction stir welding on and to apply it to more product line and help more tech transition into the U.S. industrial base.
Friction stir welding is a solid state joining process where instead of you're applying a high heat source with traditional arc welding, you're using a tool that's compressing the material and stirring the joint together. You get a much better joint configuration versus an arc weld. You get less heat, less distortion, and it's able to be used on hard to weld alloys.
CTC reached out to us after some research. They were looking for a large platform, heavy duty milling machine that would be able to potentially do friction stir welding. QuickMill selected a FANUC 0i MF Plus control. The versatility and the options that come included with that control are fantastic and meet the needs of this application perfectly. What we also did with this project is we upgraded all the servos. So the servos are the Alpha I servo system used by FANUC.
The QuickMill machine with the FANUC controls on it is allowing us to do CNC machining in a traditional form, but we're also able to do friction stir welding of materials up to 1 inch thick in aluminum, which is sort of unique for a CNC mill. We've worked with them to provide what we anticipated to be loads for the X, Y, and Z controls as well as torque.
With friction stir welding, there's a lot of reactive forces that we need to account for, as well as high torques, and we need to make sure that the machine is capable of doing these, especially whenever you get into thicker welds.
QuickMill was able to upgrade some of the motor drives to allow us to accommodate this thicker welded materials.
Because the machine originally was designed as a machining center, after you do the weld, you can actually drop off the FSW tool, pick up a face mill or a drill, and you can then do machining, the same fixturing, same part setup, so your material handling drops drastically. You're not moving it from one machine to another machine.
So having the ability to control the axes, control the Z during welding really helps in our development. We can make adjustments on the fly as we're doing it for the first run rather than having to do multiple runs. It really helps us with the research and development and process optimization.
We were also looking at how we might be able to apply machine learning and artificial intelligence to the friction stir welding process, writing machine learning algorithms that might eventually control the machine.
The FANUC control has an open architecture, which allows us to pull the machine using an Ethernet connection and specific software. We're able to collect data directly out of the control in real time.
We've been using FANUC products on the bulk of our machinery, and we've had great success with it. So when this project came forward with what we needed and what CTC needed, we knew FANUC was the right choice of controls, and by knowing the flexibility, we can make adjustments to upgrading or sizing up the motors needed to be better performance orientated for friction stir welding. We knew FANUC was the way to go with this machining center.